Welcome to our YouTube channel Sapiens Academy. Today I am planning to do MCQ questions about basic electricity and DC circuits. So just I am waiting for someone coming to our stream. Hello. No one is coming, so I am starting because if someone is coming, they don't need to miss the end. So I am starting. First, I am just reading the questions. If anyone knows the answers, you can comment in our chat box. Okay. Today I am explaining about multiple choice questions in basic electricity and DC circuits. So first question is, if anyone knows no answer, just comment in comment box. The first question is, the atomic number of an element is equal to. The atomic number of an element is equal to. We all know that. What is atomic number? It is the number of protons. Atomic number is the number of protons. Next one. Which one of the following is called as valence electron in an atom? Which one of the following is called as valence electron in an atom? There are four options are there, but we already know that, so no need for option, I think. Which one of the following is called as valence electron in an atom? Number of electrons in an orbit, number of electrons in the end shell, number of electrons in the outermost orbit, number of electrons in the M shell. Anyone knows the answer, just comment. Which one of the following is called valence electrons in an atom? I am not waiting for anyone because I don't know. Someone is interested for commenting. Just I am telling the answer. Answer is number of electrons in the outermost orbit. The number of electrons in the outermost orbit is known as the valence electrons in an atom. Next, I am telling, next question is, if the number of valence electrons of an atom is less than 4, the substance is usually. But what we tell, if the number of valence electrons of an atom is less than 4, the substance is usually, we all know that it is a conductor. Conductor means if the number of valence electrons of an atom is less than 4, we called it is a conductor. Next question, if you know the answer, just comment your answer in comment box. It will help you to improve, I to improve. If there is any mistakes I am telling, you can correct, and any extra points you have, you can add up with my question. You can, that also you can comment. Okay. Next question, atomic weight is equal to. What is atomic weight? What is atomic weight? Anyone knows? Atomic weight. Atomic weight is equal to. Atomic weight is the sum of protons and neutrons. Sum of protons and neutrons. What is atomic number? Atomic number means it is the number of protons only. But atomic weight or atomic mass, it is the sum of protons and neutrons. That is, we call it atomic weight. Next, electricity. Electrically charged atom is generally termed as we know that if an atom is electrically charged, what we call? If you know the answer, just comment. Electrically charged atom is generally termed as, we call it as ion. Ion means ion is the electrically charged atom. Clear? Next, the atomic number of silicon is 14. The atomic number of silicon is 14. It means that its atom has 14 what? This is actually a very simple question. Actually, I have to ask what is the atomic number of silicon? What is the answer? What is the atomic number of silicon? Anyone knows atomic number of silicon? What is atomic number of silicon? Just comment your answer. The atomic number of silicon is 14. 14. What is the atomic number of silicon? What it is meaning? It is the, we already know what is atomic number. It is the number of protons. But here there is no option like number of protons. So we have to carefully choose, because in these type of exams they will confuse us. They don't just give the definitions. So I will tell the option. The atomic number of silicon is 14. It means its atom has 14. Choice A, valence electrons. Choice B, neutrons. Choice A, valence electrons. Choice B, neutrons. Choice C, electrons. Choice C, electrons. Choice D, protons and neutrons together. Protons and neutrons together. What is atomic number? Anyone knows? In these options, you have to type. We already know the atomic number is the number of protons in an atom. But here there is no option like that. Only option with the protons is protons and neutrons together. We know that it is not atomic number, it is mass, atomic mass or atomic weight. So atomic number is, we all people know that number of protons equal to number of electrons in an atom. In normal atom, number of protons and number of electrons are equal. So the atomic number of silicon is 14. That means there are total 14 electrons in silicon. I think you got the answer. If you know the answer, you just comment. Your comment, I feel some support if you are commenting. Next one. Which part of an atom determines whether a material is conductor, insulator or semiconductor? Which part of an atom determines whether a material is conductor, insulator or a semiconductor? Which part it is? Which part we know that it is a conductor, semiconductor or insulator? It is valence electrons. It is depending upon valence electrons. Which part of an atom determines whether a material is conductor, insulator or semiconductor? It is valence electrons. According to valence electron, we are determining it is a conductor, insulator or a semiconductor. For a semiconductor, the shell will be half filled. Means in outer shell, if there are 8 electron space is there. If it is filled with 4 electrons, it is a semiconductor. I just told one example. So valence electrons determines whether a material is conductor, insulator or semiconductor. If you know the answer, you just comment. It will be a great support. Other people also can watch, and it will be get more people. It will reach more people. In an atom, the number of proton is. In an atom, the number of proton is. I will read the options. You can comment the options also. A, B, C, D options also you can comment. In an atom, the number of proton is A equal to number of electrons. Option A equal to number of electrons. Option B equal to number of neutron. Option B equal to number of neutron. Option C equal to the nucleus. Option C equal to the nucleus. Option D equal to 0. Option D equal to 0. Anyone know the answer? Please comment. If you like, no one is watching, I think. We can simply know that in an atom the number of proton is, it is not equal to the nucleus. Nucleus there is no number. For nucleus it is an entity, but there is no number mentioning for nucleus. Only one nucleus is there, and equal to 0 is not correct, because minimum one proton will be there in an atom. So equal to 0 is not correct. So there are only two options are there: equal to number of electrons, equal to number of neutrons. In hydrogen atom, there is no neutrons. So in an atomic structure, number of protons equal to number of electrons in normal atom. So in an atom, the number of proton is equal to the number of electrons. That is option A is correct. If you know the answer, you just comment your answer here and support. Maximum number of electrons in valence shell of an atom. Maximum number of electrons in valence shell of an atom. Anyone knows the answer? Maximum number of electrons in the valence shell of an atom. In valence shell setup, there is maximum 8 electrons only in valence shell of an atom. In any atom, in valence shell only 8 electrons will be there in valence shell. Maximum number of electrons in valence shell of an atom is 8. Next, which one of the material of the atom contains only 4 free electrons? Which one of the material of the atom contains only 4 free electrons? I am reading the options. If you know the answer, just comment the option only. Or you can comment the name also. Option A, gold. Option B, copper. Option B, copper. Option C, germanium. Option C, germanium. Option D, mica. Option D, mica. What is the answer? Of the material of the atom contains only 4 free electrons. Before we told, if in the atom there are 4 free electrons, it is a semiconductor. In these options, gold, copper, germanium, mica, only germanium is the only option. We know that silicon is also a semiconductor. So in germanium, it contains 4 free electrons. It is a semiconductor. Germanium is the answer. Option C is the correct answer. If you know the answer, you just comment your answer, or you just give your support as any comments. You share this stream to other people to see. Every day I will come with these type of general knowledge questions. Today I am telling electric about basic electricity and DC circuits. Today's MCQ is about basic electricity and DC circuits. What is a free electron means? What is a free electron? I am giving the options. You can comment the options also if you know. All the electrons in an atom. A free electron. What is free electron means? All the electrons in an atom. The electrons not belongs to the atom itself. The electrons not belongs to the atom itself. Valence electrons which are loosely attached to the nucleus. Valence electrons which are loosely attached to the nucleus. All of the above. All people will know the answer. A free electron means valence electrons which are loosely attached to the nucleus. Means free electrons means that electrons can lose to other atoms, or they can take other atoms electrons to them. The Other electrons, we can't do any bonds with the other electrons. Only free electrons we can bond. So a free electron means valence electrons which are loosely attached to the nucleus. Next question, valency of aluminium atom is. What is the valency of aluminium atoms? Valency of aluminium atom is 3. 3 is the valency of aluminium atom. So, which elements have lesser valency? Lesser valency means less than 4. It is a conductor. So aluminium is a conductor. So valence less than 4. Valence is 3. An atom, molecule, or group of an atom, molecule, or group of molecules possessing an electric charge is called. An atom, molecule, or group of molecules possessing an electric charge is called. It is very simple answer. I don't need to give options, I know. An atom, molecule, or group of molecule possessing an electric charge is called. Normal atoms don't have any electric charge. If atom with electric charge, we already told in another option, it is called ion. If you know the answer, just comment your answer also. The nucleus of an atom consists of. The nucleus of an atom consists of. What is in nucleus? What is the things are in nucleus? Anyone knows? If you know, just comment. It is a simple high school level questions or lower level question. The nucleus of an atom consists of what? Neutrons and protons. In nucleus, there are neutrons and protons. The electrons are outside of nucleus, not inside. And the protons and electrons are protons and neutrons are bonded inside the nucleus. The splitting of this is very difficult thing. We need high energy to split protons and neutrons. But electrons we can split with some simple chemical reactions or some simple pressure. Next question. If the outermost orbit of an atom has 4 electrons, the material is a. We already told about that before also. Again, question is repeating. If the outermost orbit of an atom has 4 electrons, what is the material? Anyone knows? Please comment. The material is a semiconductor. Material is a semiconductor. The electrons in the last orbit of an atom are called. The electrons in the last orbit of an atom are called. What is the electrons in the last orbit of the atom? All people know that is the thing. Electrical people, other people I don't know. Valence electrons. The electrons in the last orbit of an atom are called valence electrons. According to valence electrons, we are determining it is a conductor, semiconductor, or insulator. That type of things we are determining according to valence electrons. In a copper atom, first orbit contains. In a copper atom, first orbit contains. How much electrons in a copper atom first orbit contain? How much electrons? You know? Anyone know? Just guess. Copper is a metal, we know. All metals less than 4 electrons in the outer shell. So, copper, you guess and comment your answer. How much in outermost orbit of an in a copper atom first orbit contains. Sorry, first orbit. I am telling about first orbit, not outermost orbit. Simple confusion. In all atoms, which have 2 electrons, it is containing in the first orbit. It is its atomic structure is like that. Hydrogen don't have 2 electrons, so just forget about hydrogen. In all other atoms, first orbit contains 2 electrons. It is in oneness configuration. It is containing 2 electrons. In a copper atom, first orbit contains 2 electrons. Next question. If you know the answer, you just comment your answer also. You can use any means. If you know the answer, you can just comment and support us. More people will reach if you comment. The maximum number of electrons which the M shell of an atom can contain is M shell. Maximum number of electrons which the M shell of the atom contain is. M shell contains 18 electrons. M contains 18 electrons. When an electron is removed from an atom, it becomes. From an atom, if you remove an electron, what it is becoming? You know? Already we know an atom has a certain amount of electrons. If you remove electrons or add electrons, what it will get some charge, negative charge or positive charge. The charged atoms, what is called charged atom? Charged atom is ion. Then we have to know when an electron is removed from an atom, it becomes. Electron has a negative charge. If we remove that negative charge from the atom, it will become positive ion. So when an electron is removed from an atom, it becomes a positive ion. If you are commenting your answer, it will be very nice. According, or you comment your support also, you can comment. You tell your friends about this stream. Every day we will do the electrical questions stream. According to modern electron theory, the last orbit of an atom cannot accommodate more than dash electrons. Modern electron theory, the last orbit of an atom cannot accommodate more than 8 electrons. Modern electron theory, more than 8 electrons, last orbit of an atom, last orbit of an atom, 8 electrons. Next one, the atomic weight and atomic number of copper are 64 and 29 respectively. Therefore, a copper atom, it is a basic idea. If anyone, any people just know about the atomic structure, they can simply tell this answer. The atomic weight of copper is 64 and atomic number of copper is 29 respectively. Therefore, a copper atom has how much proton, how much electrons, how much neutrons we have to know. We know that the number of atomic number is the number of protons. So 29 protons and number of electrons is same as number of protons. So 29 protons and 29 electrons. And the remaining 35 means 64. Total atomic weight is 64. 64 minus 29 is 35. The remaining 35 is number of neutrons. Therefore, 29 protons, 29 electrons, 35 neutrons. If there are options are given, we can simply select from this. By seeing the atomic number, we know that 29 is the number of protons. So here option A, B is 35 protons, 35 protons. So A, B are already cancelled. C and D are remaining. And just to check the number of electrons, if it is same, it is the answer. So here D only the answer, 29 protons, 29 electrons. We don't need to calculate the number of neutrons actually. We don't need to waste our time. Next, the lightest particle of an atom. The lightest particle of an atom. What is the lightest particle of an atom? Actually, the atomic mass, we have to know what is the atomic mass. Then we can simply understand what is the lightest particle of the atom. The atomic mass is the total number of protons and neutrons inside the nucleus. So nucleus only the weight, nucleus only has the mass. So electrons is outside nucleus, it don't have any weight, any mass. So electron is the lightest particle of an atom. Next, the electrically neutral particle in an atom is. The electrically neutral particle in an atom is. We know that there are charges for particles. Means proton is positive charge, electron is negative charge. Proton and number of protons and neutrons are same in every atom. So these charges cancelled. So atom is chargeless. There are another particles are there, neutrons, it has no charge. The electrically neutral particle in an atom is neutrons. Number of electrons in an outermost orbit of an atom of an insulator is. The number of electrons in the outermost orbit of an atom of an insulator is? I already told the name insulator, conductor or semiconductor we are determining according to the valence electrons in the outermost shell. So if there are 4 valence electrons exactly, it is if there are 4 valence electrons exactly, it is a semiconductor. If the number of valence electrons is less than 4, it is a metal. If the number of valence electrons is more than 4, it is a insulator. Okay. So the number of electrons in the outermost orbit of an atom of an insulator is greater than 4. That is the answer. What is the difference between an atom and an ion? What is the difference between an atom and an ion? It is very simple things. Ions are always charged particles while the atoms are neutral as a whole. Ions are charged particles, atoms neutral as a whole. Inside atom there are particles like protons and electrons. Protons have positive charge, electrons have negative charge. But protons and protons and electrons are equal in number, so these charges are get cancelled together. So the atoms are neutral as a whole. Whole atoms neutral. Ions are always charged particles. If an atom lose 1 electron or gain 1 electron, it will become ion. If an atom lose 1 electron, it will become a positive ion. If an atom gains an electron, if an atom gets an electron from outside, it will become a negative ion because electron have a negative charge. Next question is conduction electrons. Conduction electrons have more mobility than holes because they. Conduction electrons have more mobility than holes because they. Conduction electrons have more mobility than holes because electrons actually electrons are the particles, but the holes are not particles. If there is no electrons, we are considering it as a hole. It is an imaginary thing. We can check the what is the optional answer they given here. Need less energy to move them. Need less energy to move them. Conduction electrons have more mobility than holes because they need less energy to move them. Okay, clear. Next one, speed of electron is a dash kilometer per second. Speed of electrons. Speed of electrons endana? Speed of electrons speed of electron is a dash kilometer per second. Speed of electron is a dash kilometer per second. The answer is 2,97,842. 2,97,842 near 3 lakh. 2,97,842 kilometer per second on speed of electrons. Next, 1 coulomb is equal to the charge of 1 coulomb. 1 coulomb is equal to the charge of. What is the is equal to the charge of We also know the answer. 6.24 into 10 raised to 18 electrons ആണ്. 1 coulomb is 6.24 into 10 raised to 18 electrons ആണ്. Free electrons existing. Free electrons existing free electrons existing where is free electrons existing? We already told that thing. There are, we can tell just some options here. Conduction band, first band, second band, third band. There are a lot of bands: second band, third band, first band. It is not depending upon the number of bands. It is depending upon outermost band, that is conduction band. Free electrons existing conduction band. In most metals that are good conductors, the number of electrons in the outermost orbit is. In most metals that are good conductors, the number of electrons in the outermost orbit is 1. Means if number of electrons is less, it will become more good conductor. So in most metals that are good conductors, the number of electrons in the outermost orbit is 1. They can easily give that electrons to another people. It will become so in most metals, the good conductors, the number of electrons in the outermost orbit is 1. Next, current conduction in metal is by electrons only. Electrons ആണ് ശരിക്കും മെറ്റൽസിൽ കറണ്ട് കണ്ടക്ട് ചെയ്യുന്നത് electrons ആണ്. ഇവിടെ കുറെ ഓപ്ഷൻസ് കൊടുത്തിട്ടുണ്ട്. ഇലക്ട്രോൺസ് ഓൺലി, ഇലക്ട്രോൺസ് ആൻഡ് അയോൺസ്, charged ions, none of this. We will get some confusions. Actually, ion is the atom itself if it is losing or gaining one electron. So atom is not a movable thing actually. Conducting thing is not atom, it is electrons itself. Okay, next. Electron distribution in germanium R. ജർമേനിയത്തിലുള്ള ഇലക്ട്രോൺ ഡിസ്ട്രിബ്യൂഷൻ എന്നാണ് പറഞ്ഞത്. ജർമേനിയത്തിലുള്ള ഇലക്ട്രോൺ ഡിസ്ട്രിബ്യൂഷൻ, ഇറ്റ് ഈസ് വെരി സിമ്പിൾ ആക്ച്വലി. We can eliminate some options here from in exams. We can eliminate because germanium is a semiconductor. In germanium, its outer shell always contains 4 electrons only. So here in 4 options are there. In 4 options, B and C not containing its outer shell with 4 electrons. So we can eliminate those things simply. The remaining 2 options A and D, but I am directly telling the answer. Electron distribution in germanium are 2, 8, 18, 4. 2, 8, 18, 4. Maybe the electron distribution of silicon is 2, 8, 4, I think. Silicon, then germanium. Next, mass of a proton. Mass of a proton is how times greater than mass of an electron. Mass of a proton is how times greater than mass of an electron. Mass of a proton is how times greater than mass of an electron. Here it is given very clearly 1840 times 1840 times 1840 times mass of a proton is 1840 times greater than mass of an electron. Next, the mass of an electron is approximately what is the answer? Mass of an electron is approximately 1 by, we already tell in another example, mass of a proton is 1840 times greater than mass of an electron. So it is the reverse question. The mass of an electron is approximately 1 by 1840 part of proton. Actually, the electron mass is very negligible mass. We consider it is a negligible mass according to atom. We don't consider the mass of an electron in their atomic mass. Only protons and neutrons are calculated for atomic mass. Who discovered the neutron? Who discovered the neutron? Who discovered the neutron? James Chadwick ആണ്. James Chadwick ആണ് ന്യൂട്രോൺ കണ്ടുപിടിക്കുന്നത്. Who discovered the neutron? James Chadwick. If you know the answer, just comment your answer also. Fuse operate due to the dash effect of electric current. Fuse operate due to the dash effect of electric current. Fuse operate due to the heating effect of electric current. Fuse operate due to the heating effect of electric current. Fuse heating effect വെച്ചിട്ടാണ് വർക്ക് ചെയ്യുന്നത്. നമ്മൾ ഫ്യൂസിന്റെ ഉള്ളിൽ ഒരു എലമെന്റ് വെച്ചിട്ടുണ്ടാവും. ഈ എലമെന്റ് കൂടുതൽ കറണ്ട് ഫ്ലോ എന്ന് പറഞ്ഞാൽ നമ്മൾ ഷോർട്ട് സർക്യൂട്ട് ഒക്കെ നടക്കുമ്പോഴാണ് കൂടുതൽ കറണ്ട് ഫ്ലോ ഉണ്ടാവുക. അങ്ങനെ കൂടുതൽ കറണ്ട് ഫ്ലോ വന്നു കഴിഞ്ഞാൽ ഇത് ചൂടാവും, ഹീറ്റ് ആവും. അങ്ങനെ ഹീറ്റ് ആവുമ്പോൾ ഫ്യൂസ് ഡിഫ്യൂസ് ആവും. അങ്ങനെയാണ് ഫ്യൂസിന്റെ വർക്കിംഗ്. Fuse operates due to the heating effect of the electric current. The material used for fuse must have. The material used for fuse must have. What is the material used for fuse? And specifications എന്താണ്? Low melting point. Melting point very low ആയിരിക്കണം and high specific resistance. High specific resistance ഉണ്ടായിരിക്കണം. Means it can resist most of the things, but melting point is less. So low melting point and high specific resistance ആണ് the material used for fuse must have. The presence of an electric current is made known by. The presence of an electric current is made known by effects produced. The presence of an electric current is made known by effects produced. There are options like option A flashing, option B effects produced, option C cracking, option D electric shock. The presence of an electric current is made known by effects produced. Next question, the flow of electric current due to the motion of charge carrier under the influence of external electric field is called as. The flow of electric current due to the motion of charge carrier under the influence of external electric field is called as drift current ആണെന്ന് പറയാം. ഡ്രിഫ്റ്റ് കറണ്ട് എന്നാണ് അങ്ങനെ പറയാം. എക്സ്റ്റേണൽ ഇലക്ട്രിക് ഫീൽഡിന്റെ ഇൻഫ്ലുവൻസ് മൂലം ഉണ്ടാകുന്ന ഫ്ലോ ഓഫ് ഇലക്ട്രിക് കറന്റിനെയാണ് ഡ്രിഫ്റ്റ് കറന്റ് എന്ന് വിളിക്കുന്നത്. ഡ്രിഫ്റ്റ് കറന്റ്. നെക്സ്റ്റ് വൺ, an electric current of 6 ampere is same as. The electric current of 6 ampere is same as. There are different units of electric current. Ampere is one unit. Another unit is 6 coulomb per second. Before that, we have to know what is the electric current. Electric current is the charge flowing per second. Means in unit time, how much charge is flowing through that part, that is called electric current. So charge, unit of charge we know coulomb. So 6 coulomb per second ആണ്. Coulomb per second is the ampere. So an electric current of 6 ampere is same as 6 coulomb per second. Next, conventional flow of electric current is from. Conventional flow of electric current is from positive to negative ആണ്. പോസിറ്റീവ് നിന്ന് നെഗറ്റീവിലേക്കാണ് കൺവെൻഷണൽ ഫ്ലോ ഓഫ് ഇലക്ട്രിക് കറന്റ് ഉണ്ടാവുക. പോസിറ്റീവ് ടു നെഗറ്റീവ്. Magnitude of electric shock. Magnitude of electric shock on a human body depends upon. Magnitude of electric shock on a human body depends upon. There are telling some options. I will read the options. Option A, current flow through the body. Current flow through the body. Option B, path of electric current through the body. Path of electric current through the body. Next, C, duration of electric shock. duration of electric shock. By reading these things, we know that all these things are depending upon the magnitude of electric shock on a human body. So the answer is all of the above. Magnitude of electric shock on a human body depends on three options. All of the above answer all of the above. Current flow through the body, it depends upon current flow through the body, path of electric current through the body, and duration of electric shock. So answer is D, all of the above. Next question. The force tending to move the electricity is called. The force tending to move the electricity is called. Anyone knows the answer? The force tending to move the electricity is called. If you know, just comment. You heard about electromotive force. Electromotive force means EMF. So EMF is the force tending to move the electricity. Next one, when a potential difference is applied to a resistor, the heat is produced by. When a potential difference is applied to a resistor, the heat is produced by due to the collision of free electrons with the molecules or atoms of the resistor. When a potential difference is applied to the resistor, the heat is produced by due to the collision of free electrons with the molecules or atoms of the resistor. ഈ ഇലക്ട്രോൺസ് റെസിസ്റ്ററിന്റെ മോളിക്യൂൾസ് അല്ലെങ്കിൽ ആറ്റംസ് ആയിട്ട് കൊളീഷൻ ചെയ്യുമ്പോൾ, ഫ്രീ ഇലക്ട്രോൺസ് കൊളീഷൻ ചെയ്യുമ്പോൾ ആണ് ഹീറ്റ് പ്രൊഡ്യൂസ് ചെയ്യപ്പെടുന്നത്. ദ റെസിസ്റ്റൻസ് ഓഫ് എ പെർഫെക്റ്റ് ഇൻസുലേറ്റർ ഈസ് ഈക്വൽ ടു. ദ റെസിസ്റ്റൻസ് ഓഫ് എ പെർഫെക്റ്റ് ഇൻസുലേറ്റർ ഈസ് ഈക്വൽ ടു. ഇറ്റ് ഈസ് വെരി സിമ്പിൾ, ബട്ട് ഇറ്റ് ഈസ് നോട്ട് പോസിബിൾ ആക്ച്വലി. Insulator means it don't conduct electricity, but a perfect insulator means no electricity is passed through that. So that means it has high resistance, means infinite resistance. The resistance of a perfect insulator is equal to infinite. Next, specific resistance of a conductor depends upon. Specific resistance of a conductor depends upon. Specific resistance of a conductor depends upon conductor material actually. Specific resistance. The resistance depends upon a lot of things. The resistance of a material depends on lot of things. It depends on its cross-sectional area, its length, and lot of matters. The resistance depends upon a lot of matters. Means if we increase the length, the resistance will also increase. If we increase the cross-sectional area, the more current will flow. That means the resistance will decrease. If you search in Google, you can see some comedy illustration of how resistance works actually. In that, we can see some cartoon characters doing something in that. You can check in. So, but the specific resistance is not like that. Specific resistance, if we increase the length, if we change the cross-sectional area also, it is not changing. It only depend on the conductor material. It is only depend on the conductor materials. Means if one material, the specific resistance is the same, another material it is different. So it is depend on the conductor material. The resistance of a metallic wire varies directly proportion to its. The resistance of a metallic wire varies directly proportion to its. Directly proportion question is directly proportion. We know that actually resistance depends on its length changing and cross-sectional area changing. If length is increasing, resistance also increasing. If cross-sectional area is increasing, resistance is decreasing because of more current is flowing through that cross-section. So it is directly proportional to the length. The resistance of a metallic wire varies directly proportional to its length. If people watching, if you know the answer, you just comment or you just put some comments to support us and share this stream to other people. They can also watch. The resistance of a 60 watt bulb will be. The resistance of a 60 watt bulb will be. The resistance of a 60 watt bulb will be. What is the resistance of a 60 watt bulb? Equal to 100 watt. The resistance of a 60 watt bulb will be equal to 100 watt. Means watt not depend on watt. So 60 watt bulb, the resistance of 60 watt bulb and 100 watt bulb are same. equal to 100 watt. When the temperature of I have some confusions about that. Just you study the resistance of a 60 watt bulb will be equal to 100 watt. When temperature of carbon increases its resistance. When temperature of carbon increases its resistance. What happens to its resistance when temperature of carbon increases? Its resistance decreases. When temperature of carbon, what about carbon? We know that carbon is a semiconductor material. In semiconductor material, it is not a conductor nor an insulator. But in semiconductor, its conductivity depends upon its temperature change. If the temperature change, its resistance decrease, means it will become a conductor. If we increase the temperature, it will become a conductor. That is resistance decreases. That is the answer. The two equal resistances connected in parallel. The effective resistance is two equal resistance are connected in parallel. The effective resistance is. If someone studying about electricity, we can simply know that if two resistors are connected in series means one after another like this, one here, it is series. If two resistors are connected in series, its resistance will add up, means its resistance increase. But they are telling the two equal resistors are connected in parallel. If parallel, its two resistors are connected, its resistance is decreasing, but two equal resistance are, it is halved. It becomes half. When the diameter of a conductor is doubled, its resistance becomes. If you know the answer, if you can use anything, you can use Chrome also. But if you know the answer, if you can comment the answer, you can comment it, or just comment your support also. Share this stream for more people who is connected to electricity, who is writing exams, which is coming electricity questions, means electrical questions. When the diameter of a conductor is doubled, its resistance becomes. What happens when the diameter of a conductor doubled? When the diameter of a conductor doubled, its resistance becomes. For this, we have to know the mathematics. Mathematics we have to know. In mathematics, what is the resistance of the diameter of the conductor doubled? If diameter doubled, what about its radius? Radius also doubling, because diameter is the double of radius. 2 into radius is diameter. So if diameter doubled, radius also doubling. What is the area of cross section of the conductor if radius doubled? The equation is pi r square. Area of cross section equation is pi r square. So if you are putting that doubling means into 2 in radius, 2 square is 4. So cross sectional area become 4 times. But we know that resistance varies. It is inversely proportional to the cross sectional area. It is inversely proportional to the cross sectional area. So if the diameter of the conductor is doubled, its resistance becomes 1/4 times. It is the answer. Next, the reciprocal of resistance is. What is the reciprocal of resistance? What is the reciprocal of resistance? If you know the answer, just comment. It is called conductance. Resistance means it resists the electron flow, means it resists the current flowing. So conductance is the opposite thing. If there is conductance, the electricity is simply conducting. So the reciprocal of the resistance is conductance. When the temperature increases, the resistance of a Eureka wire is Eureka is a stable material, and conductor, if the temperature increases, the resistance of the Eureka wire is not changed. Next, carbon has. We are just telling carbon has, so we don't have an idea about what is the answer. So I am giving the 4 options. There are only 3 options and fourth option is none of these. Okay, 3 options are positive temperature coefficient of resistance, positive temperature coefficient of resistance, negative temperature coefficient of resistance, negative temperature coefficient of resistance. C, option C, constant temperature coefficient of resistance. We are sure in any material we take in 3 options, 1 option should be correct. So none of this is not correct. What is carbon? Carbon is a semiconductor. What is the peculiarity of semiconductors? Is temperature increasing, the semiconductor will become conductor. It will conduct. Means it is opposite to resistance. So carbon has a negative temperature coefficient of resistance. If temperature increases, its resistance decreases. Carbon has a negative temperature coefficient of resistance. Resistance decreasing, so more current will flow if temperature increases of a carbon conductor. Carbon is a semiconductor, so it is happening. The power rating of bulb is higher for the same voltage rating. Its resistance will be. The power rating of bulb is higher for the same voltage rating. Its resistance will be decreased. Means power rating of bulb is higher for same voltage rating. Same voltage rating le power rating higher ആണെങ്കിൽ resistance lower ആയിരിക്കും. എങ്കിൽ മാത്രമേ ഇത് കൂടുതൽ എന്താ പറയാ ലൈറ്റ് തരുള്ളൂ. കൂടുതൽ കറണ്ട് കണ്ടക്ട് ചെയ്താണല്ലോ സ്വാഭാവികമായിട്ടും കൂടുതൽ ലൈറ്റ് തരിക. സോ the power rating of bulb is higher for the same voltage rating. Its resistance will be decreased. A circuit having 1000 ohm resistance. A circuit having 1000 ohm resistance is connected across a 1 volt. The current flowing through the circuit is. A circuit having 1000 ohm resistance. 1000 ohm. 1000 ohm resistance is connected across a 1 volt. The current flowing. We know we all know the equation. V equal to IR. So I equal to V by R. Here volt is 100 ohm, 1 by 1000. That means 1 milliampere. 1 milliampere. It is very simple question. A circuit having 1000 ohm resistance is connected across 1 volt. The current flowing through the circuit is 1 milliampere. The resistance of a thermistor dash with the increase of temperature. We already studied these things. It is asking in different questions. The resistance of a thermistor dash with the increase of temperature. Decrease. The resistance of a thermistor decrease with the increase of temperature. Means thermistor, what is what thermistor doing? If we increase the temperature, it will conduct more electricity. So the resistance of a thermistor decrease with the increase of temperature. Next, heat developed in a conductor is proportional to the square of the current. If current increases, square of the current, heat developed means the equation is I square R. I square R is the equation. We know that V equal to IR. Voltage into current. Voltage into current is the energy. Voltage equation is IR. So I into IR means I square R. I square R is the equation of energy or heat. So heat developed in a conductor is proportional to the square of the current. But square of the current increase in the square proportional heat developed. Also it is directly proportional to the resistance item directly proportional because heat in the equation I square R. So it is the square of the current resistance directly proportional heat produced in the conductor. Next, to decrease the resistance of any conductor, a resistance will be connected in. To decrease we know that how to connect resistances. If you connect two resistance in series, its resistance is increasing. If you connect one resistance parallel to another resistance, its resistance value decreases. So to decrease the resistance of any conductor, resistance will be connected in parallel. It is a very simple thing. We are all people know about electricity, they know this thing. According to which of the following has negative temperature? Which of the following? If you know the answer, you just comment or you just comment your support here. Which of the following has negative temperature coefficient of resistance? Which of the following has negative temperature coefficient of resistance? There are 4 options they are giving. Silicon, copper, iron, brass. Silicon, copper, iron, brass. We know that all other things are metals. Means copper is a metal, iron is a metal, brass is a metal. So if temperature increases, its resistance automatically increases. But in the case of semiconductor, if temperature increases, the resistance will decrease. So here silicon only the semiconductor. So which of the following has negative temperature coefficient of resistance? Answer is silicon. Next, the unit of quantity of electricity is. The unit of quantity of electricity is. Electricity unit വളരെ ഇതിൽ പല ഇത് കൊടുത്തിട്ടുണ്ട്. അപ്പോൾ നമുക്ക് നോക്കി നോക്കാം ഏതാണ് കറക്റ്റ് എന്ന് നോക്കി നോക്കാം. The unit of quantity of electricity is ampere second. Ampere second കൊടുത്തിട്ടുണ്ട്. കൂളോംബ് കൊടുത്തിട്ടുണ്ട്. Ampere per second കൊടുത്തിട്ടുണ്ട്. Both A and B എന്നാണ് കൊടുത്തോണ്ട് ഇവിടെ ആൻസർ പറയുന്നത് both A and B എന്നാണ്. The unit of quantity of electricity is ampere second or coulomb എന്നാണ് ഇതിൽ പറയുന്നത്. Next, the unit of resistivity or specific resistance is. The unit of resistivity or specific resistance is. The answer is ohm meter. The unit of resistivity or specific resistance is ohm meter. Next, electric charge. Electric charge Q. What is electric charge Q? Electric charge, the current flowing in, means what is current? We have to know first what is current. The electric charge flowing in unit time, that we called current. So in unit time, how much electric charge is flowing, it is known as current. So what is in reverse, what is electric charge? It is current into time, I into t. How much time the current is flowing? The total amount of current flowing in that time is we called electric charge, that is Q. 3 resistance of 4 ohm are each connected in parallel. The equivalent resistance will be how much ohms? If 3 resistance of 4 ohms are connected in parallel, we can calculate in mind. If connected in parallel, 1/4 plus 1/4 plus 1/4, that is 3/4. We have to reverse it, means 4/3. 4/3 is the answer. 3 resistance of 4 ohm each are connected in parallel. The resistance will be 4/3 ohms. Or we can simply tell if same resistance is there, we just divide with the number of elements. Means there are three resistance elements. So if one resistance is 4 ohm, 4/3 is the answer. Which of the following material must have negative temperature coefficient of resistance? Negative temperature coefficient of resistance. They are giving options like A, copper, B, brass, C, mica, D, manganese. Which of the following material must have negative temperature coefficient of resistance? The answer is mica. Mica is the answer. Which of the following material must have negative temperature coefficient of resistance? Mica. We know that copper, brass, and manganese. Copper, brass, and manganese are metals. Copper is a direct metal, and brass and manganese are metalloids. So mica is not like that. So for mica, it has a negative temperature coefficient. A charge of 100 coulomb. A charge of 100 coulomb is transferred in a circuit by a current of 1 ampere. Time taken by this current is dash seconds. A charge of 100 coulomb. A charge of 100 coulomb is transferred in a circuit by a current of 1 ampere. The time taken this current, we have to know what is current. Current is the charge flowing per unit time. Means charge flowing in 1 second is known as current. Here current is 1 ampere, 100 coulomb is there. So it will take 100 seconds. If it is 1 ampere, the current is flowing 100 seconds. If current is flowing 100 seconds only, it will become 100 coulomb. So a charge of 100 coulomb is transferred in a circuit by a current of 1 ampere. Time taken by this current is 100 seconds. In a parallel circuits, all components must have same potential difference across them. We just imagine what is the component. Component is not one thing. Means if we put a resistance here, if one resistance here, it is one component. Another resistance series, if we put both these resistance together, we call it one component. Here if we put 3 resistance in series, that 3 resistance at a time, it is called one component. Okay, so in each component the potential difference should be same in parallel circuit. So the question is, in a parallel circuit all component must have same potential difference across them. Next, resistivity of a conductor is the resistance between dash faces of a cube of that material. Resistivity എന്ന് പറഞ്ഞാൽ ഒന്നുകൂടി പറയാം. Resistivity of a conductor is the resistance between opposite faces of a cube of that material. നമ്മളൊരു ക്യൂബ്, ഒരു യൂണിറ്റ് ക്യൂബ് എടുത്തു കഴിഞ്ഞാൽ അതിന്റെ ഓപ്പോസിറ്റ് ഫേസസിന്റെ ഇടയിലുള്ള റെസിസ്റ്റൻസിനെയാണ് നമ്മൾ റെസിസ്റ്റിവിറ്റി എന്നതുകൊണ്ട് സൂചിപ്പിക്കുന്നത്. റെസിസ്റ്റിവിറ്റി എന്ന് പറഞ്ഞാൽ as per Ohm's law state that in a closed electric current is directly proportional to Ohm's law ennaanu parayana, closed electric current is directly proportional to voltage. Ohm's law parayana current is directly proportional to the voltage ennaanu. When I am reading some questions, if you get time or anything, you can comment your answer. It will help you and help me also to reach more people. And if you are not subscribed, just subscribe. Next question is, the reciprocal of resistance is conductance. Already we told the same thing before. If there is resistance, the more resistance, the current is not conducting. If it's less resistance only, it is conducting. So the reciprocal of the resistance is conductance. 1 mega ohm resistance equal to what is mega? Kilo എന്ന് പറഞ്ഞാൽ 1000 ആണ്. കിലോ എന്ന് പറഞ്ഞാൽ 1000 ആണ്. കിലോഗ്രാം, 1000 ഗ്രാം ആണ് കിലോഗ്രാം. അതുപോലെ തന്നെ നമ്മൾ കിലോബൈറ്റ് മെഗാബൈറ്റിന്റെ അതിന്റെ കാൽക്കുലേഷൻ ഡിഫറെന്റ് ആണ്. 1000 അല്ല, 1024 ആണ് വരിക. പക്ഷേ ഏകദേശം ആ ഒരു കാൽക്കുലേഷൻ പോലെ തന്നെയാണ് നമ്മൾ പറയാം. അപ്പോൾ 1 മെഗാ ഓം ഈസ് ഈക്വൽ ടു 1000 k ഓം ആണ്. മീൻസ് 1 മെഗാ ഓം ഈക്വൽ ടു what 1000 k means 10 lakh ഓം ആണ്. 1 million എന്നൊക്കെ പറയാം. 1 million എന്ന് പറഞ്ഞാലും മെഗാ എന്ന് പറഞ്ഞാലും സെയിം ആണ്. അടുത്തത് the temperature coefficient of resistance of a semiconductor is നെഗറ്റീവ് ആണ്. സെമികണ്ടക്ടറിന്റെ ടെമ്പറേച്ചർ കോഎഫിഷ്യന്റ് നെഗറ്റീവ് ആണ്. ടെമ്പറേച്ചർ കൂടുന്തോറും സെമികണ്ടക്ടർ മോർ കണ്ടക്ടർ ആയിട്ട് മാറുകയാണ് ചെയ്യുന്നത്. മോർ കണ്ടക്ഷൻ അതിലൂടെ നടക്കും. അതുകൊണ്ട് ടെമ്പറേച്ചർ കോഎഫിഷ്യന്റ് ഓഫ് റെസിസ്റ്റൻസ് ഓഫ് എ സെമികണ്ടക്ടർ ഈസ് നെഗറ്റീവ്. Which element is used as a semiconductor material? Which element is used as a semiconductor material? We know a lot of elements using a semiconductor material. Most of the common silicon and germanium are used as semiconductor material. Here in the options, they are giving copper, plastic, silicon bus. It is very simple silicon. They don't give more complicated things. I think minimum silicon or germanium. They will give an option. So if there is silicon, it is the answer. If there is germanium, it is the answer. The combined resistance of two equal resistors connected in parallel is equal to. We told these things again and again. Parallel resistance parallel series side connecting resistance double out. Same resistance double out. Parallel half out. Resistance capacitance resistance in the case resistance series increase resistance increase resistance parallel connect resistance decrease. So the combined resistance of two equal resistors connected in parallel is equal to 1/2 of the resistance of the one resistor. That is the answer. Next question, what is the condition of Ohm's law? What is the condition of Ohm's law? Again and again, same thing is telling what is the condition of Ohm's law. What is Ohm's law? Current is directly proportional to the voltage. There are a lot of options are given. Constant current, constant voltage. It is not correct. It will vary. Next, that two options are eliminated. Other two options, constant resistance and constant temperature. Here, resistance. We can't. We don't need to tell about resistance because its length or its cross-sectional area will be same. Resistance also will be same. So temperature should be same. That is the condition. What is the condition of Ohm's law? Temperature should be same. Next, resistivity of Eureka at 20 degrees Celsius. Resistivity of Eureka at 20 degrees Celsius. The answer is 49 into 10 raised to minus 8. 49 into 10 raised to minus 8 is the resistivity of Eureka at 20 degree Celsius. Application of series parallel combination. Application of a series parallel combination. It is a power divider right? Series parallel combination power divider right? Use either resistance in the series parallel combination power divide use. If the diameter of a wire is doubled, keeping the length constant, the resistance become. We already discussed this topic before. Resistance. What happens to resistance? You just think through a wire a current is flowing. Just think of a pipe. If water is flowing through a pipe, if its cross-sectional area increases, more water will flow. This is happening in the current also. If the cross-sectional area of the wire increases, more current will flow. That means the resistance will decrease. So if the diameter of a wire is doubled, keeping the length constant, diameter double cheyda endha sambhavikka adinte radius double avum. Radius double aayi kayna cross sectional area ku sambhavikkum. Cross sectional area equation endana pi r square. Radius double aayal 2 square, that is 4. It will become 4 times, means becoming but we know that it means cross sectional area 4 times avum. Namakkariyam if the cross sectional area changes, what is happening to the resistance? The resistance, if cross sectional area increases, the more current will flow. That means the resistance is inversely proportional. That means if the diameter of a wire is doubled, keeping the length constant, the resistance becomes 1/4. It becomes 1/4. Next, year-to-year resistance of human body. Most of the people don't know that type of things. But here we are telling year-to-year resistance of a human body 100 ohms. 100 ohms is year-to-year resistance of human body. 100 ohms. If it is a new thing to you, just tell it is a new thing. Just comment like it is a new thing. And if you know any answers, you can comment, or if you can support, you just type some comments here and share this stream for all people to watch. When 10 resistors each of 47 ohm are connected in parallel, the net resistance of the combination is dash ohms. When the 10 resistance of each 47 ohms are connected in parallel, the net resistance of the combination is dash ohm. It is very simple. Means in parallel, what happens? It will become by 10. So here 47 ohm by 10, 4.7 is the answer. When 10 resistors of each of 47 ohm are connected in parallel, the net resistance of combination is 4.7 ohms. Charge of an electron is. What is the charge of an electron is? If you know the answer, just comment. More people will attract to this stream. So I am telling again and again, and you also will get some idea. Charge of an electron is 1.602 into 10 raised to minus 19 coulomb. 1.602 into 10 raised to minus 19 coulomb. Color code for 47 ohm resistor with plus 5% tolerance. Color code of 47 ohm resistor with plus 5% tolerance. Yellow, violet, black, gold. Here, color code depends. We have to study the table of color code. So that tolerance, if it is gold, it is 5% tolerance is there. If it is silver, 10% tolerance is there. Other colors, there are different tolerance is there. You have to study the color code, then you can simply understand it. I am now just telling the answer. Color code for 47 ohm resistor with plus 5% tolerance is yellow, violet, black, gold. Yellow, violet, black, gold. You can check Google or something to find what is the answer. I know, but I am not telling you. In PTC resistor, as the temperature increases, the resistance. In PTC resistor, as the temperature increases, the resistance. What is happening to the resistance? The resistance increases non-linearly. Linearly, alla resistance increase. Non-linearly increasing. In PTC resistor, as the temperature increases, the resistance increases non-linearly. It is not proportional. Which of the following equation is correct according to Ohm's law? Which of the following equation is correct according to Ohm's law? It is very simple. V equal to IR is the equation actually. We can rearrange that things. V equal to IR. If we rearrange V equal to IR, we will get R equal to V by I. In options, R equal to V by I is the answer. According to V equal to IR, we can rearrange the things according to our option. Okay, then we will get simply the option. If a number of resistances are connected in parallel, if the number of resistances are connected in parallel, the effective resistance will be, again and again we are telling, if the number of resistances are connected in parallel, what is happening to the effective resistance? It is decreasing. If same resistances are connected, it is how much resistance are connected by that number we will get it. So answer is less than the lowest resistance in a circuit, but the option is different options are there. If a number of resistance are connected in parallel, different resistance are same resistance alla. If a number of resistance are connected in parallel, the effective resistance will be, I will tell the options, then you will get idea. Sum of the individual resistance, it is wrong. If it is in series only, sum of the individual resistance is correct. And sum of the reciprocal of the individual resistance, it is also not correct. Sum of the reciprocal, again we have to find the reciprocal. Higher than largest resistance in circuit, it is also not correct. If it is in series, it is correct, but if it is in parallel, it is not correct. Less than the lowest resistance in the circuit, that is the correct option. So if a number of resistance are connected in parallel, the effective resistance will be less than the lowest resistance in the circuit. If the area of cross section of a wire with a given length is doubled, its resistance will be, again and again same matter we are telling. If the area of cross section of a wire with a given length is doubled, what is happening? given length ആണ് area of cross section ആണ് ഡബിൾ ചെയ്യുന്നത്, റേഡിയസ് അല്ല ഡബിൾ ചെയ്യുന്നത്. It is depending upon the area of cross section. Before we are telling the diameter or radius, now area of cross section is doubling, so it is just doubling, doubled alla, it is an inversely proportional to the cross sectional area ആണ്. അപ്പോൾ b half ആയി മാറും. Next, what is the temperature coefficient of a value of value of aluminum at 20 degrees Celsius? What is the temperature coefficient of value of aluminum at 20 degree Celsius? Answer is 40.3 into 10 raised to minus 4. 40.3 into 10 raised to minus 4. What is the temperature coefficient of value of aluminum at 20 degree Celsius? 40.3 into 10 raised to minus 4. Next, 1 ampere hour is equal to, what is 1 ampere hour? 1 ampere hour is equal to 3600 coulombs ആണ്. 1 ampere hour എന്ന് പറഞ്ഞാൽ 3600 coulombs ആണ്. കാരണം ഒരു സെക്കൻഡിലെ എത്ര കൂളോംബാണ് ഇതിലൂടെ പോകുന്നതെന്നുള്ളതിനെ ആണ് നമ്മൾ നോക്കുന്നത്. കറണ്ട് എന്ന് പറഞ്ഞാൽ 1 സെക്കൻഡിലെ എത്ര ചാർജ് ഇതിലൂടെ മൂവ് ചെയ്യുന്നുണ്ട്, അതാണ് കറണ്ട്. അപ്പൊ അതുകൊണ്ട് നമ്പർ ഓഫ് നമ്മൾ ചാർജ് കണക്കൂട്ടാൻ വേണ്ടിയിട്ട് കറന്റ് ഇൻറ്റു എത്ര സെക്കൻഡ് എന്ന് കാൽക്കുലേറ്റ് ചെയ്യാണ്. ഹിയർ ദേ ആർ ആസ്കിങ് 1 ampere hour is equal to, hour means 1 hour means how much minute are there, 60 minutes. How much seconds are in 1 minute? 60 seconds. So 60 into 60, 3600 seconds in 1 hour. So 1 ampere hour is equal to 3600 coulombs. 1 micro ohm is a dash ohm. Milli we know that 1 by 1000 ആണ്. Micro എന്ന് പറഞ്ഞാൽ 1 by 1 million means 10 lakh. 1 by 10 lakh ആണ് 1 micro ohm എന്ന് പറഞ്ഞാൽ. Next question. Just comment your answer if you know. If I tell also, you can comment. It will increase your studying capacity and it will helpful for our stream also. Which of the following does not depend on the resistance of a conductor? Which of the following does not depend on the resistance of a conductor? Here they are telling length, material, voltage, temperature. Here we know that അതായത് means resistance depends upon the length. If the length is increasing, the resistance also increasing. It is directly proportional to the length. Material, if material is changing, resistance is changing. Temperature, resistance depends upon temperature. Means if temperature increased or decreased, resistance change. So which of following does not depend on the resistance of a conductor? Voltage ആണ്. വോൾട്ടേജിന് യാതൊരു ഡിപ്പെൻഡൻസി ഇല്ല റെസിസ്റ്റൻസ് ഓഫ് എ കണ്ടക്ടർ. റെസിസ്റ്റൻസ് ഓഫ് എ കണ്ടക്ടർ വോൾട്ടേജ് മാറുന്നതിനനുസരിച്ച് മാറുന്നില്ല. ബിക്കോസ് അക്കോർഡിംഗ് ടു ഓംസ് ലോ വോൾട്ടേജ് കൂടുമ്പോൾ കറന്റിന് എന്ത് സംഭവിക്കും? കറന്റും കൂടും. ഇറ്റ് ഈസ് ഡയറക്ട്ലി പ്രൊപ്പോർഷണൽ. സോ റെസിസ്റ്റൻസ് ചേഞ്ച് ചെയ്യുന്നില്ല. വി ഈക്വൽ ടു IR ആണ്. റെസിസ്റ്റൻസ് വോൾട്ടേജിനെ ഡിപ്പെൻഡ് ചെയ്യുന്നില്ല. വോൾട്ടേജ് കൂടിയാലും കുറഞ്ഞാലും റെസിസ്റ്റൻസ് മാറില്ല. നെക്സ്റ്റ്, വാട്ട് ഈസ് ദ യൂസ് ഓഫ് യുറേക്ക വയർ? വാട്ട് ഈസ് ദ യൂസ് ഓഫ് യുറേക്ക വയർ? റിയോസ്റ്റാറ്റ് ആയിട്ട് യൂസ് ചെയ്യാം. യുറേക്ക വയർ റിയോസ്റ്റാറ്റ് ആയിട്ട് യൂസ് ചെയ്യാം. ബിക്കോസ് യുറേക്കയുടെ റെസിസ്റ്റൻസിന് വലിയ മാറ്റങ്ങൾ വരുന്നില്ല. ടെമ്പറേച്ചർ മാറുന്നതനുസരിച്ച് റെസിസ്റ്റൻസ് ചേഞ്ച് ആവുന്നില്ല. അപ്പൊ അതുകൊണ്ട് നമുക്കത് റിയോസ്റ്റാറ്റ് ആയിട്ട്, റിയോസ്റ്റാറ്റിന്റെ പ്രത്യേകത എന്ന് പറയുമ്പോൾ റിയോസ്റ്റാറ്റ് ഈസ് യൂസിങ് ഫോർ കാൽക്കുലേറ്റിംഗ് റെസിസ്റ്റൻസ് ഓഫ് സബ്സ്റ്റൻസസ് അറ്റ് അക്യുറേറ്റ് ലെവൽ. So for accurate level, we need if the resistance changes according to temperature, it is very difficult. We don't get accurate level. So Eureka, the property of Eureka is its resistance does not change according to the temperature. So we can use Eureka wire as in rheostat to get accurate calculation. Next, when resistors of different values, are connected in parallel, dash across each resistor is the same. What is happening if resistors connected in parallel? What is happening? It potential drop ചെയ്യാൻ ചെയ്യുന്നത്. Connected in parallel potential difference drop ചെയ്യാൻ ചെയ്യുന്നത്. Each resistance across the potential difference drop ചെയ്യും. Each resistance we are telling. sorry, potential drop across each resistor drop അല്ല, പൊട്ടൻഷ്യൽ ഡ്രോപ്പ് സെയിം ആണെന്നാണ് പറഞ്ഞത്. പൊട്ടൻഷ്യൽ ഡ്രോപ്പ് സെയിം ആണ്, പൊട്ടൻഷ്യൽ ഡ്രോപ്പ് മാറുന്നില്ല, പൊട്ടൻഷ്യൽ ഡിഫറൻസ് മാറുന്നില്ല. ബിക്കോസ് ഇറ്റ് ഈസ് എ ബ്ലോക്ക്. പാരലലില് നമ്മൾ, ഞാൻ നേരത്തെ പറഞ്ഞു, ഇതൊരു യൂണിറ്റ് ആണ്, ഒരു റെസിസ്റ്റൻസ് ഇട്ടാലും അതൊരു യൂണിറ്റ് ആണ്, രണ്ട് റെസിസ്റ്റൻസ് ഇട്ടാലും അതിനെ നമ്മളൊരു യൂണിറ്റ് ആയിട്ട് കണക്കൂട്ടും, മൂന്ന് റെസിസ്റ്റൻസ് ഇങ്ങനെ സീരീസ് ആയിട്ട് കണക്ട് ചെയ്ത് അതും യൂണിറ്റ് ആണ്. ഇങ്ങനെ ഓരോ യൂണിറ്റിന്റെ അക്രോസ് ഉള്ള പൊട്ടൻഷ്യൽ ഡിഫറൻസ്, പൊട്ടൻഷ്യൽ ഡ്രോപ്പ് സെയിം ആയിരിക്കും. സോ when resistors of different values are connected in parallel, potential drop across each resistor is the same. അത് പൊട്ടൻഷ്യൽ ഡ്രോപ്പിന് മാറ്റം വരുന്നില്ല, ഒരേ പൊട്ടൻഷ്യൽ ഡ്രോപ്പ് ആണ് സംഭവിക്കുന്നത്. നെക്സ്റ്റ്, a short circuited path has practically dash resistance. A short circuited path has practically dash resistance. It is a zero resistance. A short circuited path zero resistance ആണ്. So all the current will flow that much high level. So in short circuited paths, if any short circuit happens, that it will damage that circuit, because infinite amount of current is flowing through this, that much high amount. So there is പ്രാക്ടിക്കലി സീറോ റെസിസ്റ്റൻസ് ആണ് ഷോർട്ട് സർക്യൂട്ട്. ഷോർട്ട് സർക്യൂട്ടിന്റെ അത് ഒരു റെസിസ്റ്റൻസും ഇല്ല. ഷോർട്ട് സർക്യൂട്ട് കൂടെയാണ് എന്ത് പോവുക, അതൊക്കെ ഫുൾ കറണ്ട് ഫ്ലോ ചെയ്യുക. ഒരു തരി കറണ്ട് പോലും അപ്പുറത്തൂടെ ഫ്ലോ ചെയ്യില്ല, ഫുൾ കറണ്ട് ഇതിലൂടെ ഫ്ലോ ചെയ്യും. the correct sequence of the conducting material on the basis of conducting is, കണ്ടക്ടിങ്ങിന്റെ ബേസിസിൽ സീക്വൻസ് എന്താണെന്നാണ് പറയുന്നത്. അപ്പൊ നമ്മൾ ഇവിടെ ഓപ്ഷൻസ് ഞാൻ വായിക്കാം. ഓപ്ഷൻസ്: എ സിൽവർ, കോപ്പർ, ഗോൾഡ്, അലുമിനിയം. ആക്ച്വലി ദിസ് ഈസ് ദ ഓർഡർ. സിൽവർ, കോപ്പർ, ഗോൾഡ്, അലുമിനിയം ആണ് ഓർഡർ. കണ്ടക്ടിങ് മെറ്റീരിയലിന്റെ കറക്റ്റ് സീക്വൻസ് ആണത്. ഓക്കെ, സിൽവർ, കോപ്പർ, ഗോൾഡ്, അലുമിനിയം. നെക്സ്റ്റ് വൺ, കോൺസ്റ്റാന്റൻ ഈസ് ദ അലോയ് കണ്ടെയ്ൻ. കോൺസ്റ്റാന്റൻ എന്ന് പറഞ്ഞ അലോയ് ആണ്. അതിൽ കോൺസ്റ്റാന്റൻ എന്നുള്ള അലോയിൽ എന്തൊക്കെ അടങ്ങിയിരിക്കും? 60% കോപ്പറും ആൻഡ് 40% നിക്കലുമാണ്. 60% കോപ്പറും 40% നിക്കലും ആയിട്ടുള്ള അലോയ് ആണ് കോൺസ്റ്റാന്റൻ. കോൺസ്റ്റാന്റൻ എന്ന് പറഞ്ഞാൽ 60% കോപ്പർ ആൻഡ് 40% നിക്കൽ. If you know the answer, you just comment your answer, or if you like the stream, you just support your by comments and like the stream if you can. The body resistance value of a human being with a normal health is about, body resistance 1 kilo ohm ആണ്. നോർമൽ ഹ്യൂമൻ ബീയിങ്ങിന്റെ ബോഡി റെസിസ്റ്റൻസ് 1 kilo ohm ആണ്. Which type of resistors are called as thermistors? NTC resistors ആണ് thermistors ആയിട്ട് യൂസ് ചെയ്യുന്നത്. The quality of a good conductor is, the quality of a good conductor is low specific resistance ആണ്. ഗുഡ് കണ്ടക്ടറിന്റെ റെസിസ്റ്റൻസ് വളരെ കുറവായിരിക്കും. ദാറ്റ് ഈസ് സ്പെസിഫിക് റെസിസ്റ്റൻസ് വളരെ കുറവായിരിക്കും. ഗുഡ് കണ്ടക്ടറിന്റെ സ്പെസിഫിക് റെസിസ്റ്റൻസ് വളരെ കുറവായിരിക്കും. ലോ സ്പെസിഫിക് റെസിസ്റ്റൻസ്. In a parallel combination of three resistance, the total resistance of a circuit is, it is very simple. We know the equation: 1 by R1 plus 1 by R2 plus 1 by R3, and total adding, it is reversing. We are reversing that. The answer is, in a parallel combination of three resistance, the total resistance of a circuit is R1 R2 R3 divided by R1 R2 plus R2 R3 plus R1 R3. Now people are watching our stream, so, and it is already around 1 hour 30 minutes. I'm getting that much thirsty. It is aching. So now I am stopping the stream. I will come to the stream, and this stream will continue. This electrical engineering stream will continue all time. So you can watch it. Thank you. Signing off. All people subscribe our channel and support us.